All right, boys and girls, we're talking about 7-7 today. The lesson's all about geometric sequences. This is a different type of a sequence. In the past, we've talked about things called arithmetic sequences. And so we'll show you the difference between those two things, I guess, with this lesson, since we asked you guys to pay attention. So here's the information. I'll make sure this is all fitting on my screen nicely. And I get my markers all ready to rock. Let's go with blue today. It seems like a blue day. I was going to say green, but then you guys would be like, oh, that's a song or a band or something. So geometric sequences. In a geometric sequence, the first term is a non-zero number, and then each subsequent term is found by multiplying by a non-zero constant. That constant is called r, and we will be using a formula to help us out with that r. And this is called a common ratio, is what that r is. So we're going to be trying to find those things to identify if we have a geometric sequence, and then we'll be again changing the names of these things as we move along. So here's our first problems. Example number 1, we have an A and a B. Our job is to determine if the sequence is a arithmetic sequence, a geometric sequence, or if it's neither. So if we look at these things, so from 0 to 8, 8 to 16, 16 to 24, 24 to 32. Hopefully you guys are all seeing that there's a quick pattern there of adding 8 every single time. Now because we're adding 8, this is an arithmetic sequence. Earlier in the year we talked about arithmetic being that you are using the A for adding, and remember that if you're adding you can also be adding a negative number because that means the exact same thing as subtracting. So those are our add subtract types of sequences. Now in example B, you'll notice that we're not exactly adding by the same exact thing every single time or subtracting. So if we take and we look at the words that we talked in before where r is a common ratio, if we look at this 48 to 64 as a ratio, so 48 over 64, I'm going to just quickly type that into my calculator, and it simplifies it to 3/4. And 36 to 48, it simplifies it to 3/4 to 48. And then the same thing, 27 to 36 is also 3/4. I used a calculator just to go a little bit quicker here. Now if you, oopsies, I wrote a 34 down. All right, 3/4. Notice that these are all the exact same number. We want to check through all of the numbers in our sequence. And since they are all the exact same number, their common ratio of r is equal to 3/4. But more importantly, this is a geometric sequence. Now in example 2, our job is to find what the next three numbers are in our geometric. So we already know that it's a geometric sequence. Our job is just to figure out what the next three numbers are. So we have to figure out what r is equal to. So that's going to be step number 1. R has to equal to something. And we can use the exact same pattern that we used before. We can do the second term divided by the first term. So a -8 over 1 equals a -8. So I know that my r is a -8. So if you notice the pattern here, we're multiplying each previous term by a -8. So again, with my calculator, I'm going to take a -512, and I'm going to multiply it by a -8. So a -512 times a -8 gives me the answer of 4,096. So that's one of my numbers. And that number times a -8 is a -32,768. And then my third number times a -8, and I'm just going to bring it down here, is a positive 262,144. So those are my next three terms in the sequence. Those got pretty big pretty quickly. Moving along here to example B, as we're trying to keep this flowing for you so you guys don't have to take too much time with me yapping at you. Again, like we did before, we're going to take the second term and put it over the first term to find our r. I just said r like a pirate. And 20 over 40 is equal to 1/2, so we know that r is equal to 1/2. So if we're trying to half each one of these, that seems like the pattern's following that pretty well. Half of 5 is 5 over 2, or 2.5. 5 divided by 2, 2.5. And then divided by 2 again will be a 1.25. Keep it easy with decimals. Divided by 2 again, or multiplying it by 1/2, is a 0.625. So all these things are going to be a little bit easier for us to make this make sense. So we could have kept this as 5 over 2, and then 5 over 4, and then 5 over 8, and that would have been the exact same numbers here. So either one of these would have been a-okay, as long as we understand that we have to figure out what r equals to, and then follow that pattern or apply that common ratio to the next three numbers. All right, now that the multiple choice question that you have is right here in front of you, use the same things that we just talked about. You'll be just fine. It's pretty simple. And then our new idea is talking about geometric sequences. There's a formula for us to be able to find any term of a geometric sequence. Very similar to what you did with arithmetic sequences, where there was that formula that shared with us how to find like the 190th term in a sequence instead of having to write down all 190 numbers. So a sub n is the term number, so what term we're trying to find. A sub 1 is the first term, and r is my common ratio. So again, n is the number that we're trying to find. Whoopsies, went too fast. So we're going to write an equation for the nth term, so we're going to leave our n's in here in the geometric sequence, and then find the 12th term. So we're going to have a part A and a part B. Now part A is, if we look at this, we need to figure out what r is equal to. So r is going to be equal to, because we know it's geometric, we're going to do the second term divided by the first term, so a negative 2 divided by 1, which is equal to a negative 2. And then our first term is this 1. So in our writing here, we're going to have a sub n is equal to the first term, which was 1, times r, which is a negative 2, to the n minus 1 power. So this is my geometric sequence. This is just writing the equation because we know what our first term is, and then we had our common ratio and n minus 1. Now part B is to plug in a 12 for our n. So I already screwed that up. A sub 12 is equal to a 1 times a negative 2 to the 12 minus 1, or to the 11th power. So in my calculator, I'm going to type in 1 times a negative 2, and I'm going to put to the 11th power just to make things easier, so I don't have to type in more math that could potentially screw things up. And I'm going to get the answer that a sub 12 is equal to a negative 2048. And that is my answer. Now I could actually calculate that out by doing 1, this is my second term, my third term, my fourth term, my fifth term, all the way through the 12th term, but I'm going to trust my formula because I'm a pretty smart guy like that. So again, you're just going to use the vocabulary words for what each letter represents, and then plug them in. So part A, make the equation. Part B, find the 12th term. All right, folks, that's how simple it is today. You have one last problem to do on your own before you come back and we go through these examples. So fill out those Google forms and we'll check with you later, folks. This is Bermination. We are signing off.